Okay, so now as you remember, so we can now start with the min term and the max term. Do you know what's the min term and max term? Okay, so now we did with this example with the min term and the max term. So now this is a 3 variable. Now we have pattern, we did it. So what is a canonical form? So in a canonical form is the sum of the min term. It's a unique form of representing something. So min terms. Min terms are the sum terms or the product terms. Min terms. Product terms. A, B, C bar is a min term. A bar, B, C is a min term. So min term are product term. So we can express any Boolean function using sum of the min term. We also call this as the sum of the min term. We call it also sum of the product terms. So now we have this examples. Can you see this example? How many functions are there? How many functions? 3. What is the name of this function? F1, F2 and F3. Okay, now can you see here in F1, now we have an F1, we have a single one. We have a single one. So single one is here. What will be the value of F1? Please help me. Help me. What should I write? X, Y, Z bar. Because there is single one. There is single one here. Okay, now if you look at F2, how can we write? How many ones are there? The first one, 1, 2, 3, 4, 5. So we can say XYZ plus XYZ plus XYZ plus XYZ plus XYZ. How many min terms? 5. We have 5 min terms. 0, 0, 1. 0, 0, 1. The first combination is 0, 0, 1. What's the second combination? 0, 1, 1. The second one. 1, 0, 0. 1, 0, 0. What should we do? Y bar, Z bar, and then 1, 0, 1, 1, 1, 0, 1, 1, 1. It will be as it is Z bar on Z, and where bar? Y bar. This is for F2. And similarly, we can derive the similar expression for F3. So F1, F2, and F3. So F1 contains 1 min term, F2 contains 5 min terms, and F3 contains 4 min terms. So all of these expression are called as the sum of the min terms. We can call it the, can you see, plus. So this is called as plus. So this is the sum of what? Min term. So this expression is called as the sum of the min term or the sum of the product. We also called as the sum of product expression. Okay, and then we can see here. So if we have F1, so F1, and then we convert this into a truth table. So F1, there is a single one here. So this is min term 6. F2, min term what? 1, 4, 5, 6, and 7. What about F3? 1, 3, 4, and 5. So these are called as the sum of the product term. Any question? Should we proceed? Should we proceed? Okay, so now F3, can you see here? F3 now contains 4 min terms, and these min terms are referred to as M1, M3, and 4, and M5. Okay, and each of the min term correspond to a particular row. It was this. So now we also say that sum of the product. Can you see here? Now we have F. Can we see it? How many ones are there in F? How many ones? 5. Okay, so in the sum of the product expression, we are interested in min terms. We are interested in min term. When we are interested in min term, so in min term we'll produce a 1 or 0. Min terms? No, 1. In min term we are interested in 1, and max term we are interested in 0. So in this case, how many min terms should be this for F? How many min terms? Look at the expression. 5. We have 5 min terms. Okay, please help me. Can you show? Please help me. Which min term is this? Which this one? This row? 3. 0, 1, 2, 3. 3, 4, 5, 6, 7. Got it? Simple. Okay, now if you look at here, now we have 0 11 1 and each minterm. So this one is 0 11 1. This is the input combination. So for the first minterm, the input combination is 0 11, then 1 00, then 101, then 110 and 111. Okay, for each of the term, when there is a 1, should you use the variable or its complement? For a 1, variable, and for 0, complement. So the same thing. So now this is an expression f which contains 5 minterm, and for each particular combination, if there is a 1, we use the variable, and if there is a 0, we use a complement of that variable. So for this case, if you say 0 1 1, it is a bar b c. Okay, now this f is a function of 3 variables. What are the name of these variable? A, b and c. And each of the minterm corresponds to a row which has a 1. Each of the minterm corresponds to a row which has a 1, and then we sum all of the minterm. So each row in the truth table has a minterm. A minterm is a product end of the literals. Each minterm is true for that row and that for that, and we explained this in our previous lecture. Remember, each minterm is only true for that row, only, not for any other row. So all Boolean expression can be written in soft form. Okay, now if you look at this Boolean expression, how many minterms? 5 minterms. How many literals? 15. 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3. There are 15 literals. Okay, now if there are 15 literals, so can you see at this expression how many AND gates? 5 AND gates. How many AND gates? So there are 5 AND gates. Each AND gate is how many inputs? 3 inputs. How many OR gate? 1. 1 OR gate with 5 inputs. So can you see here, now we have 1 OR gate which is this 1 2 3 4 5, and actually this is minterm. Can you see here? This is 0 1 2 3. So it has the input of M3 and then what? M4, M5 and 6 and M7. So we have if there are 5 minterms, so we have a 5 input OR gate. If we have 3 minterm, we require a 3 input OR gate. It is okay. Now if you look at this expression, so this expression contains now 15 literals. So if you reduce the number of literals, so please look at here. So now for this expression f, please just I'm writing this and then we can resolve. So this requires how many AND gates? 5, 3 input AND gates, and how many OR gate? 1. How many input? 5 input. Okay, now we have a generalized expression. Please think that how can we have a generalized expression? Now let's assume, please remember, let's assume if we have a function f, and this function f is of n variables. How many variables? N variables. The function f. So we have a function f of n variables, and with this function we have okay, how many literals are there for this example? 15 literals. Got it? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So now we have 15 literal. Okay, now if we have a function of n variables where there are k minterms. How many minterms? K minterms. So okay, now how many AND gates do we require? Yes, please. K. How many? 3 input. K. And input what? AND gates. Got it? Because for this example, what is K? K is 5 and N is what? 3. And then how many OR gate? 1. 1 K input OR gate. And how many literals? Got it? Okay, now what is our objective? Our objective is to reduce the number of literals. Our objective is to reduce the number of literal. How? We will see. How we will see. Okay, now for this example, so now if you look at here, so now we have this thing. So now, okay, now for any particular combination, now if now we are only interested in this example. Should I rub this off? Rub this off? Okay, now. Okay, now if you look at here, now we have some input combination 101. 101. So for 101, so now this will produce a 1 and all the other minterm will produce 0. Okay, assume we have A bar B C and then A B C A B C A B C and A B C. What is the first input? A bar B C. What is the second input? A bar B bar C bar. What is the third input? A B bar C. What is the fourth input? A B C bar. What's the last input? A B C. Okay, now let's assume if the input combination is what? 1 0 1. 1 0 1. So 1 0 1 1 0 1 1 0 1 1 0 1 1 0 1. Okay, A bar B C. Then A B bar C bar. Then this one. Then C bar. And then A B C. What will be the output for this? 0. Then 0, because 1 bar is what? 0. Then what will it produce? 1. What will it produce? 0. What will it produce? 0. So for any particular input combination, that particular minterm. So if you look at here, so 101, 101 is what? M5. 101 is M5, and for 101, M5 will be 1 and all other minterms will be 0. Got it? You got it? So for M5, for 101, M5 will be 1 and other input will be 0. So we proceed further. So this input will activate this term so that it will be 1 and no other product term will be turned on and all will be 0. So this is standard notation. If we agree on the order of the variable in the row of the truth table, okay, then we can enumerate each row with the decimal number that corresponding to the binary number for that input factor. So if you look at this truth table, we have A, B, and C. We have A, B, and C. Which one is the MSB? A, and C is the LSB. So it's the MSB, and then we can say this becomes 0, this 1, this 2. But if we change the order, so the annotation of the minterm will be different. Got it? So now in this case, so now A is now the MSB and C is now the LSB. So if we say BAC, B will now become MSB, A is the second, and C is the third. So it also need to know that the order is very important. The order is very important. So now if you look at here, 100, 100, which minterm is this? M4. This is M4 minterm. M3, M4. So now we are interested in row number 4. So and which minterm is this? M7. Small m or capital M? Small m. Why small m? Minterm. Why interested in 1 or 0? 1. So now if you look at here, F, we can write this as a sum of product. So can we write it as M3 plus M4 plus M5 plus M6 plus M7? Got it? And then we can also write this. This is the sum of the minterm of 3, 4, 5, 6, and 7. So this is alternate form. Any question? Should we proceed? Yes, please. You can. These are different representation. These are different representation. This is one representation, and that one is another representation. Yes, you can write in both. Okay, but if I say draw the logical, the Boolean expression, then we do that expression. Got it? This M3 plus M, and got it? So if we say the Boolean expression, then you have to put bar, something like that. But if we have this expression, so this is alternate representation of a particular function. Should we proceed? Okay, now if you look at here, the canonical form. Now we look at this short term. So f is the canonical form. So we can say the summation of 3, 4, 5, 6, and 7, m3 plus 4, m4 plus m5 plus 6. Can we write this expression? What is the first? 3. This one is m3, then m4, then m5, and 6, and m7. Okay, now remember, and now this is very important. I need your attention here. Everyone attention here. So if we have the canonical form is not equal to the minimal form. Can you see this expression? So f is this. Got it? Okay, now look at here. Should I rub this off? Now look at this. What is the expression? Please write me the expression and then we can solve it. F is equal to what? ABC plus ABC plus ABC plus ABC plus ABC. How many terms? 1, 2, 3, 4, 5. So 0, 1, 1, 1, 0, 0, then 1, 0, 1, then 1, 1, 0, and then 1, 1, 1. Okay, now can we rewrite this? Because which one is common? What is common? A B bar is common. Where is A B bar? This term and next term. These two terms are common. When these two terms are common, what we can do? So we can say A B bar. Can we write C bar plus C? Yes? Am I right or not? Can you see here? So these two terms, what is common? A B bar. Okay, now in these two terms, what is common? A B. What we can write? C bar plus C. And now the first term. What is the first term? B C. Okay, now C bar plus C is equal to what? 1. So this one is equal to A bar B C plus A B bar dot 1 plus what? A B dot 1. Got it? Now what's now the next? A is common. So A bar B C is equal to what? Plus A B bar plus A B. Then A bar B C plus what is common? A plus B. Then A bar B C is equal to plus A, because this is 1. And this is equal to A plus B C. Why? So can you see here? This is A plus A bar B C is equal to A plus B C. How? Can anyone prove this? Anyone? Can anyone prove this? A plus A bar B C is equal to A plus B C. Let's assume if I ask this question in exam, what will happen? Okay, think. So we remember, please remember. So we say, so now there is a theorem, and I will prove this. So I will say A is equal to A plus M is equal to A plus A bar M. What is A plus M? What is M here? BC. This one. So this is A. So can we say A plus A bar M is equal to what? A plus M. And what is M? BC. So now this is M. But we need to prove that A plus M is equal to A plus A bar M. We need to prove it. How? So can we write something like this? What is A plus M? Can we write something like this? A plus M is equal to A plus 1 dot M. Yes? A plus 1 dot M. How can we further expand it? A plus A bar M. Because what is A plus A bar? 1. A plus AM plus A bar M. A plus M is equal to A plus 1 dot M. and a plus a bar m is equal to a plus m. Okay. Now what should we take common? No, m, because we want to exclude m, so we can take m common, then a plus a bar, which is what? 1, and a plus m. So please remember, if you remember this theorem, so a plus a bar m is equal to a plus m. Okay, now this is one way. This is one way. You can also this is okay. Now you remember, I asked this question. Prove that some left hand side is equal to right hand side. This was method number 1. You now use method number 2. Now we have a and m. How many combination? 4 combination. 0 0 0 1 1 0 and 1 1. And a plus m. What will be a plus m? Yes, please help me. 0 1 1 1. Okay, now we need a bar m. A bar m. What will be a bar m? 1. A bar m is 1 and it will become 0 0 and then 0. Okay, now we need 2 columns to add a plus a bar m. So now we have a plus a bar m. So this is, to do this we need a, and we need what? A bar m, and then we need 0 0 0 0 1 1 1 0 1 1 0 1. So is it a bar m and a plus m? They are same or different? Same. So now we have proved that a plus a bar m is equal to a plus m using 2 methods. What is method number 1? Truth table approach. What is method number 2? The Boolean expression or the algebraic manipulation. We call this as algebraic manipulation. Got it? So now we have this algebraic manipulation. Got it? Here, everything is clear or not?
I don't understand.
Which?
The method to Boolean.
Okay. A. Which one? The second one. A plus m. A plus 1 dot m. Can I write it? What is 1? Got it? And then a plus a multiplied by m. M. A bar m. Clear? We take m common. When we take m common, so it will become what? And a plus a bar is what? 1. So a plus m dot 1 is 1. M.
But how does that go with the a plus a bar?
Which one?
RHS, the red color. Above it.
Ah, you're right. You're right. You're right. You are totally right. So okay. Now we take a. You are totally right. Very good. 1 plus m plus a bar m. He's very much right. Because we are saying this. So a 1 plus m. 1 plus m is 1. A dot 1 plus a bar m, and this is a plus a bar m. Now we have side that left hand side. Very good. Very good observation. Very good observation. So this is, so now I really like this observation, because you're also identifying my mistakes. Got it? And it means that now you're concentrating, and this I really like this approach. Understood? Because now you have, what say, now we have, this is LHS and this is also LHS, and what is this? RHS. So now we have proved that LHS is equal to RHS. So you can take a screenshot of this, and please, this is my request from everyone. This is my request. Whenever you take a screenshot of this, so please raise your hand and say, I promise I will try and practice at least once at home. And if you do, and you do all the tasks that I'm doing in the class, believe me, at least one, not more than that, at least once, then you will help. It will help you a lot. And this is not about, sometime also stuck, but it's also a matter of practice. Now, if you look at here, please look at here. If you look at this expression, this is an expression, and in this expression, how many AND gates do we require? How many AND gates? This one 2 input AND gate and one 2 input OR gate. So this implementation is better or this implementation is better? This one. Why? We have less delay. We reduce the less number of gates. We reduce. So in this case, if you remember, for the same function, for this function, we need how many AND gates? 5. 3 input AND gates. 1 5 input OR gate. But for this implementation, how many gates? 1 AND gate, 1 OR gate. How many literals? 3 literals. 3 literals. So now we have reduced the number of literals. Our objective in for the upcoming, for the upcoming topics, we want to reduce from this expression to the bottom expression using another method, which is called as Karnaugh map. But at this point, we are just only, going. So now, how did we reach to this expression? How did we reach to this expression? Using what? Using algebraic manipulation. This is called as algebraic manipulation, and we use all the theorems of the Boolean algebra. Any question? Should we proceed? Okay. Now, from logic gate to sum gates, the sum of the product term leads to two-level logic. Can you see here? Two-level logic. First, we need an AND, and then we OR. So this is the first level is what? AND gates, and the second OR gate. How many min term? 3. And there are also some inverters. So now we have a variable and its complement form. How do they are called here? Each of them is called as, yes, literal, because either we have A or A bar, we have B or B bar, or C or C bar. So on this hand side, on this side we have literals, okay, on this side we have min terms, and now on this side this is a SOP expression. Literal, min term, and then SOP expression. Got it? Should we proceed? Everything understood? Okay, max term. The max term or the sum terms. Max term, okay, min term or the product terms. Remember, they are dual of each other. So if min term are the product terms, the max term or the sum terms. For Boolean functions, the max term of a function of the term for which the result is 0. For min term, the result should be 1, and for max term, result is 0. Boolean function can be expressed as the product of min term. It's the product of min term. That expression is called as sum of product expression, and this expression is called product of sum expression. So now, please look at here, and this is very important. Okay, so for the previous example, were we interested in 1 or 0? 1. And for the max terms, 0. How many zeros for F1? F1 is not there. How many zeros? 7. 7. So actually, can you say for F1? So now, should I rub this off? So can you say please look at here. What is F1 now? The product of what? Except all the max term except 6. So it is actually capital M, not small. M0. You cannot directly. 0, 1, 2, 3, 4, 5, 7. Got it? And what about F2? How many zeros? 1, 2, 3. So 0, 0, 2, and 3. Can you see? 0, 2. And then for F3, how many zeros? 0, 2, 6, and 7. 0, 2, 4, and 6. And can you see here? Now we want to find just what is this? M0, M1, and M2. We want to calculate M2, capital M2. What is the binary of 2? How should we write it? X, Y, and Z. Yes. How should we write? X plus Y bar plus And similarly, this is only for M2. This is intentional. So then I want you to wake you up. Okay. So this is sometime I will do this kind of mistakes in intentional. This is called as intentional mistakes. Okay. So now we say that now we can have this M2, and then can you see that F3? So F3 is 0, 0, 0, 0. M2 0, 1, 0, 1, 1, 0, and then 1, 1, 1, and 1, 1, 1 for the last term. 1, 1, 1. X bar plus Y bar plus Z bar. Got it? Okay. Now there are some interesting observations. There are some interesting observations. So why is this so? So now let's assume we have F2. Now forget about other thing. So we can say we have F2. So can you see F2? How many zeros are there in F2? 3. So can we say, okay, now we are saying now we are doing why this. So take F2 as an example. So F2 is sigma. In sigma we are interested in min term or maximum? Min terms. F2, how can we write F2? 1, 2, 3, 4, 1, 4, 5, 6, 7. 1, 4, 5, 6, and 7. Got it? Okay, now please look at here. Now we have 3 variables X, Y, and Z. This is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Now we have F2. F2 is 1 at which 4, 1, 1, 4, 5, 6, and 7. So now this is F2. Okay, now what will be F2 bar? F2 bar. What should be the output? 1, 0, 1, 1, 0, 0, 0, 0. So can we say, so F2 bar is nothing but the remaining combination. What is missing here? No, 0 is missing here. 0, 2. So can you see 1, 2, 3, 4, 5? There are 5 combination, and there are how many combination? 3. And how many total combination? 8. So if there are, okay, so can you see? Now we need to generalize it. Okay, now if we have, now please we want to generalize it. Okay, now if we have a function of n variables, we have a function of n variable. What is n here? N is 3. So if we have a function of n variables, so we have a total of how many combination? 2 to the power n. In this particular example is 2 to the power 3. How many combination? 8 combinations. We have a total of 8 combination. Okay, now if we have a function, has a function, please, a function, let's say function k. A function k has t min terms. A function k has t min terms, and t is always, remember that t is always smaller or equal to 2 to the power n. So if a function has t min term, the function k bar will have how many min terms? No. Very good. 2 to the power n. And remember that this t should be smaller or equal to, because this t should be smaller or equal to 2 to the power n when all of them are ones. Got it? So now you need to think that how it works. So now if we have, okay, so if we have a function of n variables, how many combinations are there total? 2 power n. So t cannot exceed to 2 power n, because you can, let's assume if you have 8, so t cannot be 9. T cannot be 9. T can be either 0, 1, 2, 3, 4, 5, 6, 7. Got it? So t is the number of terms. So t, if he has t min terms, so the function k bar will have how many combination? 2 to the power n. So now can you and put this n is equal to 3 and this example. Got it? Should we proceed? Okay. Now can you say, so now if we have a function, this we have a function. How many combination? 5. So what is t? T is 5. And then what is 2 to the power n? 8. So how many combination do we have? 2 to the power n minus k, which is actually 5. How many combination? 3 combination. And then you need to solve it in a very. Is this clear? Should we proceed? Good. Okay. So from previous slide, so we can say f2 bar, f2 bar. So now f2 is equal to m0 plus m3 plus m3 bar. Why? Which expression is this? f2 bar. f2 bar. So now, should I rub this off? Then I will explain this. I will explain this. Should I rub this off? Take a screenshot. Good. Okay. Now we have f2 bar. So f2 bar is what? m0. Why m0? Plus what? m2 plus what? m3. Which expression is this? The sum of the product term. Got it or not got it? So can we say m2 plus m2 m0 plus m2 plus m3? Okay. Now we want to take we want to find f2. So can we say f2 bar whole bar is equal to what? m0 m2 plus m3 whole bar. And when it's f2 double bar, it becomes what? f2. So f2 is equal to m0 bar dot what? Dot what? m3 bar. Now look at here. It's very important. It's very important. Now if you look at m0, m0 is what? The min term. Is it a function? It's a function of what? X, Y, Z. So can we say X, Y, Z dot X, Y, Z dot X, Y, Z. Okay. 0, 0, 0, 0. 0, 0, 0. Got it? And then you put a whole bar. M2. What is M2? 0, 1, 0. 0, 1, 0 bar and then whole bar. And M3. 0, 1, 1. 0, 1, 1 and then whole bar. Got it or not got it? Okay. Now can we write? How do we write it? Yes, please. Plus Y plus Z, because you know it becomes double bar and then what? Dot and plus, not plus, X. Got it? Which theorem? De Morgan's theorem. So you need to practice. You need to practice all of these expressions, that how you derive from one expression to another expression, and this expression is very important. Good. Okay. Now we have the product of the sum expression. We have another form of representation. So any Boolean function can be represented in the form of sum of product, which is called as the sum of the min term. Each min term will correspond to a 1 or 0. 1. it can also be represented in the product of sum, which is another form of representation. So it's a De Morgan's of f, a product of sum term. Are we interested in 0 or 1? 0, because it's product of sum. Got it? So this is okay. Now if you look at here, now we are interested in how many zeros are there? 3 zeros. 1, 2, 3. What does it correspond to? A plus B plus C. A plus B plus C bar. A plus B bar plus C. Got it? And these are the expression. So this is okay. Now this is max term M0. This was max term what? 1. And this one is max term M2. Capital M or small m? Capital M. Now these are the product. Each sum term represents one of the zeros of the function. Can you get it? Okay, now 0, 0, 0. Okay, now when we have a 0, so we take the variable or its complement form. For 0, the variable, and for 1, complement. Got it? So this is actually the dual of each other. The SOP and the POS are the dual of each other. Okay, now if you look at here, product, and for this in particular input, the output will be 0 or 1? 0. Can you? This 0 is 0 and all other terms will be 1. Got it? So now this is for this particular term, can you see here if this is 0, 1, 0? So 1 will become what? 0, and this will become 0, and all this will be 1. Because 0, 1, 0, if 0, 1, 0, B is 1, it will become 1, and it will become 1. And it will implement an AND gate. So anything ANDed with 0 is 0, output will be 0. Okay, now consider an example. A is equal to 0, B is 1, and C is 0. This is the expression. We give this input 0. Which row we are activating? Which row? First row, second row, third row? The third row. We activating the third row. Okay, now if you look at here, these are all the values. So this is the product of sum or sum of product? The product of sum. So now we take a sum. Can you see here all of these two inputs, these two input produce a 1 or 0? 1. And this third input 0. Got it? That's the reason that it produces 0. So this is the product of a sum term, and anything ended with 0 is what? 0. And that's the reason for the product of sum we are interested in 0 or 1? 0. And for all of these combinations, for all these remaining combinations, it will produce a 1. How to write it? Now we have this term, max term. Find the truth table rows where f is 0. 0 in the input column, true literal. 1 in the active column, complemented. Okay? Or the literal to get a max term. Got it? Okay, now we have the canonical POS form. Okay, now we cover all of the possible combination. What is this? Capital M0 or small m0? Capital M1, capital M2 until capital M7. And why it is bar, bar and bar? All of them are 1. M6. Okay, how do we write it? 0, 1, 2. Got it? Okay, now it's very important. This topic is very important. Min term to max term conversion. Okay, now, and everyone will be confused with these kind of things. Okay, now if we have a function of 3 variables, okay, and that variable is ABC. Okay, now if we have the min term of M3, M4, M5, M6, and M7. So M3 will be 1, M4 will be 1, M5 will be 1, M6 will be 1, and M7 will be 0. Capital 9 small. And the max term, will be what? 0, 1, 2. So they are. So can we see here for this function f2? This okay. Now if you look at here, so f2 is the sigma of what? 1, 4, 5, 6, 7. And how can we write f2 here? The pi of what? 0, 2, and 3. Got it? Okay. Now max term. So now what we are doing? We are converting for a min term expression to a max term expression for the same function. Same function or different function? Same function. Now if we are given maxed the product of some expression, we can convert it to the sum of product expression. This is the product of some expression m012 pi 012 is the product of some expression, and this is what? Sum of product expression. So now we can convert from one function to another function directly. Now it's important. This one is very important. This is a little bit complicated. This is expansion of f to f bar. So now if we have an f, if we have an f which is actually what? 3 4 5 6 7, then f bar, can you see? F bar is the same sigma, but it was the same example. Can you this example? So if it covers how many combinations? 5. It will cover the remaining 3 combinations. So now if we have a function f and they are in sigma, which is actually the sum of the product, so then we have an f bar of the same function, the complement function. So for this combination, m3, m4, m5, m6 and m7 will be 1, but m0, m1 and m2 will be 0, because now we are complementing the function. And this is the example. Then we have f2 and then we have f2 bar. Got it? Now we have another example. So now and this is actually, can you see here? Now this is f of f bar. F, not f bar is this, and f is this. So this is a function f, and then we have 0 1 2, and for f bar it is equal to the min term. Got it or not got it? So now this is all how it works. These are all. So now we can convert from one expression to another expression. Okay, now can you see here? Okay, now please look at here. This f2 is a summation of what? 1 4 5 6 and 7. Okay, now what is f2 bar? How can we write f2 bar in the form of sigma? Yes please, f2 bar in the form of sigma. 0 2 3 0 2 3. And how we write f2 bar in the form of pi? In the form of pi, f2 bar, not f2, f2 bar in pi. 1 4 5 6 7, 1 4 5 6 7. Okay, now we have a relationship. Can you see? Now if we have f and f, so this is the conversion from what? From the past expression to the SOP expression, from the past expression to the SOP expression of the same function or the complement function, same function. Okay, now we have f2 and then we have f2 bar. Can you see here? Now we are given f2 in pi, we get f2 bar in sigma. Now can you see here? Now we are going from f2 to f2 bar. So f2 is now in sigma and we are going to f2 bar in pi, and these are all the relationship. And you need to understand this relationship using all these truth table, and then I have also proved it. Got it? So these are all the conversion from one expression to other expression. These are conversion from one expression to other expression. Okay, now if we have a function f in sigma, we can also get the same function f in pi. If we have a function f in sigma, we can also get the same function f bar in pi or sigma. So all these things. So now these are different combination from one expression form into another expression form. Okay, now this is a task. This is a task, and I want you to concentrate on this task. Okay, please, and then I will solve each and every task. Put up your pen and pencil. Please put up your pen and pencil. And I'm going to rub it. And this, so question number 1. Now question number 1. Question number 1. Now we have a Boolean function of 5 variables. How many minterms can we have? Possible. How many possible? 2 to the power 5. So we can have a maximum of how many combination? 32. We can have maximum of 32 minterms and we can have a maximum of 32 maxterm. The same thing is true for maxterm and same thing is true for maxterm. Got it or not got it? Okay, now please look at here. Given a function f, f is what? Sigma m 57. Which one of this is correct? Which one? 057. Why B? Because for this we have 1, 1 and 1, and for other combination 0, 1, 2, 3, 4, 5, 6 and 7. So which option is better? B. So now we have converted. So I can give you any function, and please remember. So now for this combination we will have a 0, and for this combination we will have a 1. It covers all of the possible combination. How many combination? Total 8. 1, 2, 3, 4, 5, 6, 7, 8, and all of them are not replicated. Got it? Okay, now the third one. How can we get the third one? Given a Boolean function f x y z is equal to y bar x plus z bar plus x bar z. Okay, now I can hide this thing. How can you evaluate? Okay, no, not truth table. Forget about truth. You can also use the truth table. You can also use algebraic manipulation. How? Expand. Yes. So can you see here? Now we have f. I'm not looking at the solution. What is f? Y bar x plus what? Z bar plus what? Or z. Now we want to expand it. Okay, now which expression is this? Sigma. It is the sum of the product expression. It should include all of the literal. It should include x, y, and z. So can we say something like this? X, y bar plus what? Z bar plus what? Z. What is missing here? Z. So can we write something like this? X, y bar, then Z bar plus y bar, Z bar. What is missing? X plus x bar Z. What is missing? What? Got it? And then we can say x y bar Z plus x y bar Z bar plus x y bar Z bar plus x bar y bar Z bar plus x bar y Z plus x bar y bar Z. Okay, think 101. Why 101? Got it? 100. Then 100. Why 1? X is 1, y is 0 and 0. What about 000? Then what? 011. Then what? 001. Okay, so now this is equal to f sigma of m. What is this? Oh, yes. Yes. I am saying 101, 5, 100, 4, 100, 4. You can, because we need it only once. So a, this is, can you see? This is now, let's assume this is a n plus a. A plus a is what? A. A plus a is a. So we need to add only 1. So 4 is 1. So we write 4 once time. Which expression? 0, 3, then 1. So now we can we rewrite it? 0, 1, 3, 4, 5. Where is 0, 3, 1, 3, 4, 5? T. Got it or not got it? Because these are the questions, and please, and this is my request to everyone, what is your job? Let's assume that I will ask the same questions, and I will give you this with an example. You know, you came on the day of the mock quiz. I gave you a 2's complement addition. Did I give you the problem or not? What was the size of n at that time? 11. I solved in the class an 11-bit addition. I asked in the quiz about 8-bit. Did I reduce the complexity or increase the complexity? Reduce. And still, most of the student face the problem in these 2's complement addition. Why? What's the reason? You didn't practice. So this is the same problem. So now I solved it on my own. You say, oh no, everything is easy. But if I ask the same question in an exam, so maybe everyone is then stuck with that thing. So now what's the good approach to do this? So these are the tasks. Don't look at the solution. Okay, you can take a screenshot of this, but try to solve these 4 or 5 times. Then you will come to know your problem. Got it? Should we proceed? Okay, now about this. Given a Boolean function, and now this is very important. This is a very important thing. Given a Boolean function with 6 variables, given a Boolean function with 6 variables, A, B, C, D, E, and F. What is the maxterm M60? What is the maxterm M60? Without looking into solution, I can solve it. Okay, now if we have a variable of a function of 6 variable, so it can range from 0 to 63. From 0 to what? 63. What we are interested? M60. M60. Okay, now this is the same thing. Remember, 1, 2, 4, 8, 16. You can use any method to convert. Okay, how can we get 60? 60 is what? Plus 48 plus what? Because you know 32 plus 16 is at 48. 32 plus 16. 48 plus 8. 56 plus 4. 60. So 1, 1, 1, 1, 0, 0. And please look at the order of variables. I told you. Which one is the first one? A. Which one is the second one? B, C, D, E, and F. So M60 is the maxterm or the minterm? Maxterm. For the maxterm, so how do we write it? A plus B bar. Did I look at the solution? It's there. Which option is this? C? Yeah, it's C. Got it? Okay. Now, if in the exam, so okay, I solved it, and if in the exam, okay, what? Okay. Now this is M60, maximum or minterm? Maximum. If we say small minterm, M60. If I ask this, they say, oh, you solved it like this. If M60, so I take a dual of it, bar on this maxterm. What is this? Yes, please. A, B, C, D, F bar. If I say instead of M60, okay, now what about M? What is, if we say, assume that we want to have another, let's assume we say 17. How can we get 17? 16 plus 1, 0, 0, 0, 0. So M6, 17. Help me. Help me. Yes, please. M17. Yes. No. M, capital. A plus B bar plus D plus E F bar. What is M17? Small. A, B, C, D, E, F. Okay, 0, 0, 1, C bar, D bar. Got it? How to solve these kind of things so you can have. Okay, now the fifth one is a little bit complicated. The fifth one. Given a Boolean function f, should I write this up? Given a Boolean function f is sigma of what? M 0, 2, 5, 6 and 7. Okay, this is actually what? M0 plus M1 from M2 plus M5 plus M6 plus M7. Got it? Okay, now if the input combination is 0, A is what? B is what? 1 and C is what? 1. 0, 1, 1 is correspond to what? Convert it into M3. Is M3 here? No. If M3 is not here, what should be the result? 0. So this A. M3 is not here. Okay, if we say, if this combination is, let's assume 1, 0, 1, it will give me 1. Why? Because M5 is here. 1, 0, 1 is equal to what? 5. And the same thing, maybe, okay, now this I am giving the sigma, but if I say the pi, then it's opposite. So think of all these things. Think of all these things that how do you solve it. So think, so now I may change, so I can change the Boolean function. I can increase the number of variables. Maybe I will give the same question in the exam, but I may increase the number of variables. I may use sigma here, I may use pi here. I can change the options here. I can, instead of giving this option, I may put a blank. So these are the questions I'm telling you in advance. These are the questions. For the first question, we say 6 variables. I can give you 5 variables. I can give you 4 variables. I can ask for a min term. I can ask for a max term. So if I'm a teacher, so I say, okay, how can I have different kind of questions? So these are all of the possible combination of questions that I may ask in the exam. The same thing, the Boolean function. It's a function of 3 variables. I may ask a function of 4 variables. I may ask a function of 5 variables. If we have sigma, I can make it 5. I can make it sigma. I can put different numbers here. So these are the things. The sixth one. The sixth example. Yes, please.
Can you repeat the sixth one?
Didn't, no problem. No problem. Okay, now if you look at the fifth one, 0, 2, 5, 6, 7. So for all these entries, it will be 1, 1, 1, 1, 1, and 1. And for what? So now for what are the remaining combination? 1, 3, and 4. We'll have 0. Yeah. So if the combination is 0, 1, 1. So okay, now draw the truth table. Okay, it's very easy. I will draw the truth table.
Oh, yeah.
Got it? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. What is this? M0, M1, M2, M3, M4, M5, M6, and M7. Now we have sigma for 0. It will be what? 1. For 2, 1. 5, 6, 7. 5, 6, 7 are 1. What are zeros? Now, if you say 0, 1, 1, it is equivalent to what? Got it? Any question? Please, if you have any, if you didn't understand, please ask me. Okay, now question number 6. Question number 6. Okay, which of the following is not a min term of the Boolean function? I can say it directly. Which of the following is not a min term? I can say it directly. I can directly say, because for this expression, I can directly say, what is missing here? Y. What is missing here? W. What is missing here? W and Y. Either we expand expression and we get a lot of expression and we got it. But I can Directly answer which option is this. Think which option will be there. C? No. No. Why? And why C? Why C?
Because there was no complement.
Which one?
There was no complement.
No. Can you see which of the following term is not a min term? Which is not included? Which is not included? X is included, X is included, X is included. So we cannot put X bar. So whenever there is an X bar on X here, it is not included. And here, E. You got it or not got it? Either you expand it. Okay, now there are two methods. Either you expand it, okay, you will find it that okay, these four will be included. Can you see here? Okay, now WX is there and Z bar is there. WX and Z bar is there. Now use Y. So we can have WX Y bar Z bar, WX Y Z bar, both are there. Okay, now this is not excluded. The second term, W bar X Y bar, W bar X. So X and Z is here, X and Z is here, and X is here. So this is included. Got it? Now the third one, WXYZ. What is included? X is included, is there. Now we have all forms for it. Now if you look at here, WXY bar Z bar, WXZ bar is included. When WXZ bar is included, so this is new. And this one is not included because there is no X bar. So now think, and then you think you can also expand this expression. You can also, so there is an intelligent answer. You can directly say, oh yeah, I'm confident on that. Okay, now identify the following function. Yes, please. Which one?
Can you just expand the X? Let's see how will you expand it.
Oh, it's not a problem. It's so simple, man. So if we say xz, so what about there? W plus W bar. So you can say WXZ plus W bar XZ. Got it? So we include W. Now what is missing here? X, no Y. WXZ Y plus Y bar plus bar XZ. Got it? So this is how do you expand. So whenever one variable is not included, so you add one variable, then add the same variable and its complement again because it's one. Okay, now what we are doing? Now we are doing this one is reduced one, XY is reduced one, and this one is expanded. It requires less literal, and the other one requires more literals. Okay, now identify the following function f x y and z. Which function is this? How do you solve it? You can draw the truth table of all. So, but if you say it, so you can say that which one is there? Which one? So it's your homework. It's your homework. Try to do and solve this on your own, and try to do it on your own. So now this is your homework, and then you can try this on your own. Okay. So I know that the time has passed.